Okay, now, firstly, we want everyone to draw a rectangular shape. Alright? Okay. Now, for this rectangular shape, we want everyone to draw another one. Alright, so it's two, I divide that into two rectangular shapes. Okay, now, if this is 2, this is 3, this is 4. Now, I want everyone to tell me how can I calculate area 1, A1. It's not difficult, right? What is the area of A1? 2 times 3, very good. So A1 equals 2 times 3. Alright, length times width, that's it. Alright, now, how about A2? Area 2. It's 2 times 4. Alright, is that correct? Yes, good. So that is 2 times 4. It's the same. Length times width. Okay, so this side is 2. So 2 times 4. Okay, very good. Any other questions? Now, if I say this is A2, the whole area, how can I calculate the area? The whole area. A1 plus A2, very good. Alright, can I say 2 times 3 plus 2 times 4? Is that correct? Okay? And also, can I write like 2 times, I want you to tell me what could be in the bracket.
3 plus 4.
Raise your hand because we want everyone to think.
3 plus 4.
3 plus 4, very good. Okay? Do you have any other questions? Good. Now, let's continue. We want everyone to continue to draw another square. Okay? Same thing. Okay, but this time, now last lesson we said number can represent something. And also prenumerous has the same function as numbers. They still can do the calculation. Alright? So if this side is 2, the area 1 is 2 times 3 because the length of this side is 2. Now, how about this one? What is the area of A1? What is the area of A1? What is the area of A1? A plus 3? A times 3. Alright, the same. This is 2, so 2 times 3. So if that is A, that's A times 3. Okay? So in algebra, do we write A3?
3A.
If we write A3, that is a paper, right? A3 paper. Okay? So we write A1 equals 3A. Very good. So 3A means 3 plus A? Very good. So 3A means 3 times I. Okay? Because if I write multiplication sign here, you may think in algebra situation that is 3xa. So to avoid this kind of mistake, we just write nothing. 3a. Very good. Now, we want you to continue. Write A2. What is the area of area 2?
4A.
A4?
4A.
It's a paper. Alright, it's 4a. Very good. It's 4a. Now, we want everyone to write the whole area. The whole area is A1 plus A2. Can I write 3A plus 4A? Okay? Like here. 3A is A1, A2 is 4A. So 3A plus 4A. No problem. And what can I write here?
A bracket 3
A bracket 3 plus 4. It's the same like that because it's A, that is 3 plus 4. Does that make sense? It's the whole area. Okay, the whole area here is 3 plus 4. That is A. Okay, very good. Now, everyone, I just want to ask you a question. So this length is A, is that correct? Can this length be B, C, D? Okay, good. Now, I want to use another color. You don't have to draw another one, all right? If this one now is not A, this one now is x squared. This length is x squared. Now, we want everyone, okay, I changed another color, it's not very clear, right? So we change it to blue, right? So if this side now is not A, this side now is x squared. I want you to write down A1 and A2. Please do that by yourself, okay? Now, the side is not A anymore. The side is x squared. Just now I said it doesn't matter this is A or not. Alright, so I can really use x squared. Alright, could you please tell me what is area 1? What is She said that is 3x squared. Is that correct? Yes, good. So 3x squared. 3 times x squared. You don't have to care about what have been written down here. How about A2? 4x squared. Very good. So 4x squared. Now, how about A? Oh, it's very clever. This is 7x squared. But how can I calculate that? I'm not very interested in your answer. I'm interested in how you put them together.
3x squared plus 4x squared.
3x squared plus 4x squared. Very good. Equals, actually, that is x squared 3 plus 4. Okay? X squared 3 plus 4. Now, the last thing I want everyone to try, this is your last chance to have a try. Now here, it's not x squared anymore. So the length of this side is a squared b. I want you to calculate. A1, A2, and A. Sure, A1 on board. No, we want a boy? Yeah. Right, A2. What is the area of A2? Okay, that's 4, right? 4a squared b, no problem. Alright, so if you have problem, raise your hand and we're going to sort it out straight away. Okay, so the whole area, we add them together. So that is 3a squared b plus 4a squared b. Now, what is another way to calculate that? This is 3, this is 4, we can add them together. So that is a squared b, 3 plus 4. Alright, do you have any questions? Okay, good. Now, what I want everyone to have a look at this, I want you to have a look at this writing, and this writing. What are they in common? What are they in common? Oh, some people, because we learned that in year 8, they are like terms. Alright, so you have 3a, 4a, 3x squared, 4x squared, and then a squared b and 4a squared b. So they are like terms. Is that correct? Okay, good. Now we want everyone to write down this. Okay, follow me to write down. So 3a, 4a. And 3x squared, 4x squared. And 3a squared b, 4a squared b. They are called like terms. Alright, very good. Now, from your observation, could you give me the concept of like terms? What are the like terms like? The same per numeral, very good. This is A, this is A, this is X, this is X, this is AB. We have AB here. Very good. Same per numeral. So they should have the same per numeral. Alright, per numerals. That could be one or could be more. Very good. And the same per numerals. Okay, very good. Now, we want everyone to have a look at. Some people are very smart because they saw I wrote 1 here. There should be 2. Okay? Alright, good. But let's have a look at the first one. Tell me, are they like terms? Some people said no. I want to know the reason. Are they like terms? Did you say no?
Yeah, but then I realized it.
You realize they are like terms, right? So firstly, let's have a look at here. Do they have the same per numerals? PQ? PQ. Do they have the same per numerals? Yes. Probably they are like terms. And some people say no, probably you think this is 5, this is negative 3. Here, 3, 4, 3, 4, 3, 4. The number is called coefficient, is that correct? So, do you have to check the coefficient? No, you don't have to check the coefficient, right? Because for 3, that is 3 lots of x squared. This means 4 lots of x squared. It doesn't matter how many x squared. As long as I have got x squared, they are like terms. This is the same. This means 5 lots of PQ. This means negative 3 lots of PQ. Does that make sense? Okay? Alright, good. So they are like terms. Now, alright. I want to put that board. So you can see 5Q and negative 3x. And negative 3PQ, they are like terms. Good. Alright, they have the same per numerals. Here. Are they like terms? Some people said yes, or who said it's no? It's not, they are not like terms. Could you tell me the reason they are not like terms? Oh, he said they're different order. Very good. Some other opinion. I want you to pop up your opinion. That's very important. Although it's not correct, it doesn't matter. Okay?
Because 7 times 3 and 3 times 7 are the same thing, so it doesn't really matter what way you put it.
Oh, she said 3 times 7. What is 3 times 7? 21. What is 7 times 3? 21. So 3 times 7, 7 times 3. Do we care about their order? No. So it's the same here. It's A, B, B, A, the same thing. Yes. Okay? So in this case, are they like terms? Very good. They are like terms as long as they have the same per numeral. Alright? The same per numerals. It doesn't matter the order. Okay? Alright, it doesn't matter the order. Very good. So I put that here. They are like terms. Alright. 4AB. Okay. This one. Alright, when you do the judgment, you have to follow the concept, same per numeral. Do they have the same per numerals? Yes? A and B, are they like terms?
Because the two.
Okay, now I put that here and I make some notes. Now, who can explain? Some people said no. Who can explain why they are not like terms? Oh, some people mention the power. That's very good. But why we have to check the power? Why do we have to check the power? Who can explain that? So this is correct. This is correct. They are not like terms. Why? All right. We want everyone to listen. Okay.
For example, if A is 3 and B is 4, 3 squared is not the same as 3 plus 4 squared.
Oh, he used the real number. All right. He put the number in and then to check the answer. That's a very good way. Okay. So if that A is 3, B is 4, that is 3 times 4 squared. Is that correct? But this one will be 3 squared times 4. Definitely you will not have the same answer. Does that make sense? Okay? And also, everyone, can you tell me what is B squared? B times B. So this one is A, B, B. Is that correct? This one is A, B. Do they have the same number of the prenumeral? No. For here, you have 2B, you have 2A. So, do they have the same prenumeral? Actually, no. Okay? So, that's very important. We want everyone to write in another color. Number 2, they should have the same power. Same prenumeral with the same power. That is very important. So, if A to the power of 1, here should be A to the power of 1. If this is B to the power of 2, here should be A to the power of 2. Okay? Do you have any questions? Good. So, when we judge like terms, you have to follow these 2 rules. Okay? Now, another easy thing. Are they like terms? Now, if not, tell me why they are not like terms. Why they are not like terms? Why they are not like terms? Very good. This one has C in it, but this one has no C. Alright, very good. So, they don't have the same numerals. Okay, very good. So, AB and ABC, they are not like terms. Good. Alright. Are they like terms? No, in math, you should not say maybe. There's no maybe in math. Follow this, the same pronumers, same power, are they like terms?
No.
Are they like terms? No, why? Not the same. Same what? Prenumerals, right? Do they have the same power?
Yeah.
Yes, to the power 5, to the power 5. And then they don't have the same prenumeral. Very good. So they are not like terms. Good. So they are not like terms. Alright. Okay. Next one is a little bit challenging. Are they like terms? Are they like terms?
No.
Who said no? You said no. Okay. You said no. Why it is not? They are not like terms.
Oh, but yeah, they are.
No. She changed the.
They got the same. They got same prenumerals, different coefficient.
Oh, okay.
No matter what coefficient, so they've got the same power and they're the same. Yeah, because like.
All right. Now let's have a look at the entire explanation. Could you tell me, you change your idea? You say yes, why?
So the actual prenumeral is x squared. But
I just have one question. Is pi a prenumeral?
no. It's coefficient.
Very
Pi
good.
is a number.
Pi is, yes, very good. Pi is a number. That is very important, everyone. Pi is not like a x squared, ab. Pi is not like that. Pi is not prenumeral. Pi is 3 point something. That is a number. Is a constant number. So this is a coefficient. It's not the prenumeral. So have a look. Do they have the same prenumeral? Very good. Do they have the same power?
Yes.
Yes, to the power of 2. So, very good. They are like term. Now, I want everyone to write these down into your book. Alright? This pair is very important. Write down here. They are like terms. Alright, so put that here. Okay, they are like terms. Okay, good. Now, if they are like terms, we can do some calculation. The reason why we want to have the like terms is we want to do the calculation. Okay? We're gonna make the questions easier. Now we want everyone to have a look at from here to here. 3a plus 4a becomes the one, right? So let's have a look at this example. Example 1. So 3a plus 4a equals, we said a, 3 plus 4. Now, like what I said, 3 plus 4, is that a number? It's a number. So what do we normally put the number? At the back or in the front? In the front. So normally we write like that. 3 plus 4 lots of a. Okay? Alright. Now, definitely the answer is 7a. But I want everyone to tell me, how did you calculate, how can you collect like terms? From this step to this step, what did you do? Alright? We continue, right, to copy down this one. Example 2. So this example, you guys said that is 3x squared plus 4x squared equals 3 plus 4x squared equals 7x squared. Okay? Now, we want you to observe. And also the last one, example 3. So you've got 3a squared b plus 4a squared b equals 3 plus 4a squared b. So that is 7a squared b. Now, we want you to tell me, how can you collect like terms from this step to this step? From this step to this step. How can you collect like terms? If you have like terms, how do you do this calculation? That is not called expanding. This is actually called factorization. But later we're going to talk about that. For this one, what do I do for the coefficient? Put them together. Very good. Alright, so when we collect like terms, we want everyone to write down the procedure. Okay? Now, everyone write down the procedure. So the steps. First step, you need to do the calculation of the coefficient. Okay, like here, you have 3 and 4, you add them together. And how about my prenumerals? How about my prenumerals? So this is 3a plus 4a, that's 7a. Is that 7a squared? Some people always got confused about a squared because a and a, so they write a squared. What do I do for the prenumeral? Here, x squared, x squared, x squared. a squared b, a squared b, a squared b. What do I do for the prenumerals? What do I do? Stay the same. Very good. So, the prenumeral stay the same. Okay? You do not square them. So if you cannot remember, or if you say, oh, I totally cannot understand, look at this area. We want everyone to combine the shape with algebra. And it's easy to remember. Everyone look at here. How long, so for this one, if that is A, how long is this side? A. How long is this side? A. How long is this side? A. Do you do A squared? No. It's always A. Okay? The side will not be changed. So you can remember like that. It doesn't matter how long is that. A stay the same. Alright? A stay the same. So you add the coefficient and then the prenumerals stay the same. Okay? Do you have any question? Good. Now we want everyone to copy down this question. Alright? So that is example 4. Okay. 4x squared plus 2x plus 7 plus 3x, take away 8x squared, take away 2. Alright, now for this question, we want to say if x equals 2, find the value. Alright, if x equals 2, find the value. Now, everyone, I just want to ask, if I put 2 here, x equals 2, so that is 4 times 2 squared, and then this x is 2, this x is 2, this x squared is also 2. Do you think that is easy to calculate? Alright, you have to write, you have to calculate a long thing. Alright, so in this case, we're going to simplify first, and then we substitute to find the value. Okay? Alright, now let's simplify. Now for x. Now when we simplify this expression, we want to collect like terms. Alright, so the first step, what you have to do is draw lines. Okay? Draw lines to find the like terms. Alright? Draw lines to find the like terms. Okay, for example. Now in your homework, I want to see everyone, you draw the lines to avoid mistakes. Okay? Now, firstly, let's do some revision. For this expression, how many terms are there? This is from last week. Some people say 6, is that correct? Alright, let's count 1, 2, 3, 4, 5, 6. That's very good. Okay, now, let's draw the lines for like terms. I want to start from the beginning. So this term is 4x squared. So I draw one line. Alright, follow me. Draw one line. I need to see that in your homework. Alright, in your homework, everyone draw the lines. Okay. Now, is there any like terms of 4x squared? Oh, some people said 8x squared, very quick. Oh. What is the like terms of 4x squared? What, it doesn't matter.
What?
What is the like terms of 4x squared? Which one is like? Negative
Oh no, but it was 8 squared.
x squared, 8x squared. This is very important. Negative. Okay? Now, we want everyone to include the sign negative 8x squared. Any other like terms of the x squared term? No? Good. Alright, so let's continue. Have a look at this one. 2x squared. Is that 2x squared or negative 2x squared or something? 2x squared. Good. Now, we draw two lines. Okay? We want everyone to draw two lines. How about the like terms? 3x, very good. Is there any negative signs? No. Alright, good. So include the sign in one. 3x. How about the last? What are they called? Constant term. Very good. Some people did the revision. So they are constant term. Now I want you to tell me what are the constant terms. What are the constant terms? Yes.
The ones that don't have a friend.
Yes. So that is 7 and
-2.
-2. Very good. This is what I want. Okay. All right. Good. Now the next step. We rearrange. We write one line together. Okay, so that's why I want everyone to include the sign. When you rearrange, you need to put them together with the sign. So that's why this is 4x squared, take away 8x squared. Continue. Plus 2x, plus 3x, plus 7, and take 2. Okay. We can only calculate like terms. 4x squared take away 8x squared is negative 4x squared, and then here is 5x and plus 5. Now, for this one, everyone, you can see this expression is easier than this one. So you can substitute 2 here and then continue to calculate the value. Alright? We're going to show all the workings to everyone next lesson.